Today we are working the January 2023 CSEC Math Exam, paper 2, so let's get right into it. Question 1. By rounding each number in the expression below to one significant figure, estimate the value of root 108 over 19.72 plus 5.296. So the square root of 108 to one significant figure, that's 10, and 19.72 plus 5.296 rounded, that would give us 25. So 10 divided by 25, that's 0.4 rounded to one significant figure. Next, fraction. Find the exact value. Of course, we can use our calculator, or we can just, let's work it, show the working. So converting 3 and 3/8 to improper fraction, 8 times 3, that's 24, and 3, that's 27 over 8, divided by, now in the bracket, we have two fractions here. LCM would be 12, so this is 5/12. And 1/3, we can write 1/3 as 4/12s, right? So 1/3, we can rewrite that as 4/12s. So this is 27 over 8, divided by, add these two fractions, we get 9 over 12. So we can multiply and invert, so this is 27 over 8 times 12 over 9. Let's try reduce this to its simplest form now. So 9 into itself, that's 1. 9 into 27, that's 3. 12 and 8, we can divide each of them by 4. 4 into 8, that's 2. 4 into 12, that's 3. So now we're multiplying two fractions, numerator times numerator. So 3 times 3, that's 9. Over denominator times denominator. 2 times 1, that's 2. So 9 over 2. But the one else, the things as a mixed fraction. So that's 4.5 as a mixed number. Due to the COVID-19 pandemic, the number of available seats in a hall was reduced from 125 to 93. Calculate the percentage decrease in the number of available seats. So percentage decrease, or percentage change in anything, so percentage decrease is the actual decrease over the original amount times 100. So the decrease, so notice it fell from 125 to 93. Let's work out the decrease. So it fell from 125 to 93. The difference will give us a decrease. The original figure was 125. So times 100. So 125 minus 93, that's 32. So 32 over 125 times 100. And that should give us approximately 25.6%. So the percentage decrease is 25.6%. Move on. So Micah invests a certain amount of money in a bank that pays compound interest at a rate of 2.5% per annum. At the end of 2 years, the value of her investment is $7,564.50. Calculate the amount Micah invests. So the amount Micah invests, that would be the principal. So notice we are given the accumulated amount, the value of the investment. So we are given A, which is the accumulated value, which is 7 plus substitution, so 7,564.5 in the formula. The principal, we do not know, is that the amount Micah invests. This is the amount I want to find. And then 1 plus, and the rate is what, 2.5%? So it's 2.5, which is rate R over 100. And N is the number of years, 2 years, so 2. So let's simplify this and try to find the value of P. Principles, 7564.5 equal to P, the bracket. So notice in the bracket, this is 1 plus 2.5 over 100. No, 2.5 over 100, that's what, 0.025. So we add that to 1, that's 1.025 squared. So that's 7564.5 equal to 1.025 square. That's what? It's 1.050625 times P. Now we want to find the value of P, so we divide both sides by 1.050625. So divide both sides by this. So the thing itself is 1. So the principal is 7,200, and that's the amount that Micah invests, 7,200. Let's move on. This is poorly written. Let me just rewrite the problem since this is not so clear. So this is, we're asked to calculate x squared all cube. And the law of indices says we can just multiply the power, so that's x to the power of 6. This one is y to the power of 8 divided by y to the power minus 5. Law of indices says that if we're dividing, same base y, so it's divide, so we multiply, we add the powers, dividing, we subtract the powers. So we subtract since we're dividing, so y to the power of 8, and the power, subtracting powers, so minus, and the power here is minus 5. So this becomes y to the power of 8 plus 5, hence y to the power of 13. Next, factorize. Notice a common factor here is y. So we factor out y. We're left with x minus y. Notice when you expand the bracket, you get xy minus y squared. Here, difference are 2 squares, so this will be straightforward. So this is x plus y, x minus y. Hence, simplify the expression here. So we just rewrite the numerator as y into x minus y when factorized. And the denominator, difference of 2 squares, x plus y into x minus y. Which x minus y can divide into itself. So we are left with y over x plus y as our solution. The diagram below shows 2 rectangles, M and N. Here they are. M, N, with their dimensions expressed in terms of x. Given that the difference between the areas of the 2 rectangles is 64, show that x squared minus 2x minus 35 equal to 0. So we are told the difference between the 2 areas is 64. Let's find the area of M. Or the area of M, so the area of rectangle M minus the area of rectangle N, we are told that the difference is equal to 64. Alright, let's calculate the area of rectangle M. Notice rectangle, so length times width. So rectangle M, that's 3x plus 4 times x minus 3 minus, and the area of N n, again, is x minus 3 times x plus 2. So area of m, area of n, and we're told the differential is equal to 64. Let us expand. So 3x times x, that's 3x squared. 3x times minus 3, that's minus 9x. 4 times x, that's 4x. 4 times minus 3, that's minus 12. Let's do the other bracket. X times x, that's x squared. X times 2, that's 2x. Minus 3 times x, that's minus 3x. Minus 3 times minus 2, that's minus 6, equals 64. So continuing, we have 3x squared, we have minus 9x, we have positive 4x, we have minus 12. Let's distribute the negative now to each term in the bracket. Minus x squared, so it's as if we are multiplying each term in the bracket by minus 1. Look at it like that. So minus 2x, minus that's positive 3x, and minus 1 times minus 6, that's positive 6, equals 64. Let's group all alike terms now. So in terms of x squared, we have a 3x squared, we have minus 2x squared, so minus x squared, so 3x squared minus x squared, that's 2x squared. Let's group the x terms now. So we have minus 9 plus 4, that's minus 5. Minus 2, that's minus 7. And plus 3, that's minus 4x. The constants now, we have positive 6. I could group the 64 over here. So that would be 6 minus 64. Oh, there's a minus 12 also here, so that minus 12 equal to 0. So this becomes 2x squared minus 4x, and now this is what now? Minus 76. 6 is minus 70. Is it? Minus 70 equals 0. And of course we can divide each term by 2. So divide both sides by 2. We get x squared. Divide by 2, we get minus 2x. And minus 70 divided by 2, that's minus 35, equal to 0. So we have completed the proof that we're asked to do, right? Let's move on. The following diagram shows three quadrilaterals, P, Q, and R on the square grid. Q and R are the images of P after it underwent different transformations. Let me just use this. Alright, so Q and R represent different transformations of P. Alright, so notice P transform to Q, this looks like an enlargement, and P transform to R, it seems to be a rotation. Alright? Okay, so let's see what they're asking us to do now. On the same grid, draw the image of quadrilateral P after a translation by the vector. Label this image P image. So we're asked to translate quadrilateral P using the translation 10 negative 4. Now 10 negative 4 means, remember we're moving in the x direction, so the top value represents a horizontal movement. So 10 to the right, since it's positive 10, and the second number negative represents the vertical movement. Negative 4 means 4 down. Alright, so for each vertex in P, we're going to move it 10 to the right and 4 down. Alright, let's do that. So here's P. We're going to move each vertex 10 to the right and 4 down. So let's start with the top vertex. So 10 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 4 down. 1, 2, 3, 4. Alright, so that's 1 point. Let's move a 1 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 4 down. 1, 2, 3, 4. Alright, so here. And of course this vertex will obviously be here. Alright, let's move the one at the bottom there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 4 down. 1, 2, 3, 4. Brings us here. So this, of course, you should use a ruler. I'm using freehand there. Since I don't have a ruler, I just. Alright, so I use ruler and connect all these vertex. And this is P image. What is P image? P image is P translated by the vector 10, negative 4. So each vertex will move 10 to the right and 4 down. Alright, let's see what else they require of us. Okay, and the same grid. Draw the image of the quadrilateral P after a reflection in the line y equals 0. Label this image P double prime here. Alright, so P, we're going to reflect it in the line y equals 0. Now the line y equals 0, is the x-axis. So pretty much we're being asked to reflect P in the x-axis. Alright, so the x-axis will be what we call a mirror line. Alright, so reflect P in the x-axis. Alright, so notice, let's look at it now. So here's P. Alright, so here's P. How far is this point, this vertex from the x-axis? Let me see. 1, 2, 3, 4. So 4 down. So 1, 2, 3, 4. Here. Alright. And this means this is 4, 5, 6, 7. And the top will be 7 down. So 3 more. So that would be 1, 2, 3 here. Alright, this point, this vertex, how far is it from the x-axis? Let me see. 1, 2, 3, 4, 5, 6. So the image will be 6 down on the other side. Alright. So 1, 2, 3, 4, 5, 6. And of course the image will be over here. So we can, of course, you should use a ruler. Since I don't have a ruler, I'm just using freehand. This P double image. And this is a reflection of P in the line y equals 0, and the line y equals 0, same line as the x-axis. Right, next. Next, we're asked to describe fully the transformation that maps triangle P onto, quadrilateral P onto quadrilateral Q. Let's look back at the diagram again. So we're asked to describe a transformation that maps P to Q. And obviously, it is a enlargement, right? So what we can do is just measure 2 lines. So to describe the enlargement, I need the scale factor, and you can choose any 2 corresponding sides, or like let me just use here. If you measure this length is what? 1, 2, 3, 4, 5, 6, 6 units. This length is what? 2 units. So notice was stretched by or enlarged by a scale factor of 3, first of all, from 2 to 6, sorry. So the scale factor is K. So the scale factor K right? Notice you can also use the length of two corresponding sides. We also need the center of the enlargement. Now, how do we get the center of the enlargement? We connect any two corresponding points. So we can connect these 2 points, of course, using a ruler. And where these 2 points intersect, 2 lines intersect, then that will be the center. So I can connect that, like those 2 corresponding points. And if I connect 2 other corresponding points using a ruler, so we can connect these with a straight line. Alright. Notice where these 2 lines intersect, where you of course use a ruler. This is a point what? Negative 10.7. So the center of the enlargement is minus 10.7. So the center of the enlargement is minus 10, positive 7. We were also asked to describe the transformation that maps triangle quadrilateral P onto quadrilateral R. Let's look at what. Alright, so here was P, here's R. Obviously this is not a reflection. It's obviously its size seems to be the same. The areas of the shape seem to be the same, so it's not an enlargement. So look, it was turned or rotated. Alright. So we need the angle of the rotation. We need the center of the rotation. Alright, so to get there, seem to be a 90-degree angle, because if you compare this corresponding point, well, the angle seems to be 90 degrees anti-clockwise. Notice this. Notice here, if you realize it's compared, like it's turned, so to speak. This point is rotated almost like that. That's a 90-degree turn anti-clockwise. Can we get the center of the difficulty here to get the center? So this is a rotation. So this is a rotation, which is 90 degrees anti-clockwise. That's how I would describe it. Question 4, lines L, here's L, and line M are drawn on this grid below. What are we asked now? Write down the coordinates of the x-intercept of L. X-intercept of L, that's where L cuts the x-axis, that's here. So L cuts the x-axis at the coordinate 6, 0. So that's 6, 0. Okay, let's do the one. The y-intercept of the line M. Oh, here's the line M. M cuts the y-axis. This point is what? 0, negative 2. So M cuts the x-axis, the y-axis at 0, negative 2. That's how we ask to find. The equation L is, let me just write it better, is x plus 2y minus 6 equals 0. Find the value of k, given that the point 9k, so the point 9k lies on the line. So notice the coordinates here. The first value represents the x, and the second value k represents the y. So we can substitute them since they would fall on the line. We can substitute them into this. So we replace the x with 9, so that's 9. I replace the y with k, so 2y becomes 2k minus 6 equal to 0. Group the let's group the numbers on the right hand side. So this is 6 minus 9. So 2k would be minus 3. If I divide both sides by 2, so k is negative 3 over 2, or negative 1.5. Find the equation of the line M in the form y equal mx plus c. Alright, so remember in the format here, C represents where the line cuts where the line M cuts the y-axis. So the line M, where is it? The line M cuts the y-axis as -2. So for M, the C value here will be -2. So what we want is really the gradient of the line, the gradient of M. And to get the gradient of M, we can really select any 2 points on the line. Let me select this point. For M, let me select this point. This point is 3, 4. And let me select this point. This point is 1, 0. Right, so I'm going to call this x1, y1. Let me call this x2, y2. And this is all about finding the gradient of the line M. So for the line M, y2 minus y1 over x2 minus x1. So y2, that's 4 minus 0 over x2 minus x1. That's 3 minus 1. So that's 4 over 2. 4 over 2, sorry. Which is equal to 2. So the gradient of the line M is equal to 2. And it cuts the line cuts the y-axis at -2. That's the C value. Remember, C represents the y-intercept. So M is 2. So for this, alright. So y equal mx. So M is 2. And the constant is where the line cuts the y-axis, which is -2. Next, show by calculation that the line L and M are perpendicular. Now, if the two lines are perpendicular, that means the gradient of L times the gradient of M should be equal to -1 if two lines are perpendicular. Now the gradient of M, we know it, we found it a while ago to be 2. So now we know the gradient of L. Let's get the gradient of L. Gradient of L. Alright, so here's the line L. The gradient, to notice gradient, another way of finding gradient, we can use rise over run. Alright, notice for L, let's just take this section of the line L. Section of line L. Notice the rise here is 3, and the run here is 6. So the gradient here is a half. Or you could find the gradient the same way you found the gradient of M, which is using this formula. And you could select any 2 points. Here a point here is 0, 3, and here a point here is 6, 0. Apply the same formula, and you'll get the gradient of L to be a half. Alright, so the gradient of L is half. Well, -half, since the line is falling. What is the line L? As you move from left to right, it's falling. Alright, so the gradient is a half. Another way of getting the gradient of L is to rearrange it. Rearrange this by transposing for y. Notice if I transpose for y here, I would have 2y, and bring over x and the -6. Negative x bring over as -1x, and -6 over as +6. If I divide each term by 2, so 2 into 2. Notice y equal -half-x. Alright? So this is the gradient. The coefficient here of the x, which is -1/2. This is 3, where the line cuts the y-axis. But we're not interested in that. It's just the gradient we want, -half. So -half times 2, that's -1. So since the product of the gradient of L and M is -1, then these two lines are perpendicular. Right, now line L and M represent the graph of a pair of simultaneous equations. Using the page and the graph on page 11, write down the solution to this pair of simultaneous equations. So is where L and M intersect. Where L and M intersect, that would be the solution to the, here notice L and M, they intersect here, the point 2, 2. So the solution to the pair of simultaneous equation of the lines here will be x equal to 2 and y equal to 2. Question 5. The cumulative frequency curve shows information about the times taken by 200 students to solve a math Olympiad problem. So here's a cumulative frequency curve on the y-axis there, and the time taken there on the x-axis. Right? Use a curve to find an estimate for the number of students who took more than 50 minutes to solve the problem. Alright? So more than 50 minutes. Alright, so if you look at 50 minutes, use a ruler. Here's 50 minutes. Use your ruler, draw a line, come right up, draw a line, come right up, and the line would stop there. Alright, and if you draw now a horizontal line come across now, right? To touch the vertical axis or the y-axis there. Alright, this should be about, based on the scale we are using here, it's 185, 184, 188, 192, 196. So each thin line value 4. So this seems to be 196. Each thin line value 4. This seems to be 196. So between 196 and 200, that's 4. Alright, so the number of students that take more than 50 minutes will be 4 students. The median time, so the median, to get the median, we'll find half of the cumulative frequency. Now the cumulative frequency goes up to 200, half of that is 100. So we draw a line from 100. So this was from 50 go up. Alright. So we draw a line from 100 till it meets the graph there, and then we come down with it. And the corresponding value on the x-axis or the time axis. This for the time axis. Each thin line value 1, so that seems to be 34 or 35, 34. Alright, so median time taken 34 minutes. Actually, this looks like 33, 31, 32. Well, based on my graph, it's more look like 33. Alright, next. The probability that a student chosen at random took at most 28 minutes to solve the problem. Let's find 28 minutes. 28 minutes. So 28 minutes. So let's look for 28 minutes. So 28, that would be 2 behind the 30. Alright, so 28 would be about here. Bring it up, bring it up, bring it up. 28 minutes. Alright, so this can then go across with after you touch the curve. This seems to be 64 more, so 64. So 28 minutes or less. So at most 28 minutes mean 28 minutes or less, right? And that's 64, so that would be the probability would be 64 out of the total of 200 students. So, probability, we can express it as a decimal, 0.32, or we can also express it as a percentage. Alright, any of those forms would be okay. So, 0.32 or 32%, whichever. Let's move on. Using the cumulative frequency curve on page 13, complete the table below. Alright, so notice we're asked to do the cumulative frequency. We're asked to complete the frequency table. Let's look at the cumulative frequency curve again. Notice the second, well, for 20. So the first point was 10 or 10.5 to 12. The next one, 20. Use 20.20. So 20, Note each thin line on the vertical is 4, so 24, 28, 32, well, approximately about 36. So if you cumulate the frequencies 36 for the second one, then this would have to be 24. Now note that all the numbers must add to give 200. Since the cumulative frequency was 200, if I add all of those numbers, I get 166. So to make it 200, it would have to be 34. Alright, so that's our table. In terms of the midpoint, let's finish complete the table now. So midpoint is the x value, the value in the second column times the value in the third column. So 5.5 times 12, 6.6. 15.5 times 24, that's 372. Next one is 45.5 times 34, that's 1547. Now the sum of the frequencies should be 200, same as the cumulative frequency, same as n, by the way, the number of persons. And the sum of the fx, sum of the final column there, that is a 66, plus 372, plus 1071, plus 2982, plus 1547, plus 222, that's 6260. So average time taken, same as mean, is the sum of fx over sum of the frequencies, same as n. So that's 6260 divided by 200. I'm getting approximately 31 minutes. .3, so down for 31 minutes. Alright, let's move on to question 6. So question 6, we have a track here. Notice the track is basically a rectangle in the middle and a semicircle on either end. Alright, show that total length of the running track is 350. So the track, basically we want the perimeter of the track, right? Of this shape. So this would also be 98. Good. Perimeter, notice, so it's basically two semicircles. So the track is really, and the perimeter is really L to M, N to P, this semicircle, and also this semicircle. Alright, so which is really a circle. So the track is really, the perimeter of this track is really 98 and 98. So that's 2 times 98 plus a circle. Can notice a circle here. This is a semicircle. This is a semicircle. So and the perimeter for our circle is 2 pi r. Alright, so 2 times 98. 2 times 98. That's 196 plus 2. We are told to use pi as 22/7. And the radius, notice the radius. The radius 49. This is also 49. So the radius will be half of the diameter. Half of 49. That's 24.5. And we can use our calculator to calculate this. The question says we should get 350. So P, perimeter, or the length of the track is 196 plus, all this works out to be 154. And then we end up with 350 meters. Nathan walks at a constant rate of 1.4 meters per second. Calculate the time it will take him to walk 7 laps. Now 7 laps. So remember one lap was 350 meters, right? So 7 laps will be 7 times 350, which is what? which is 2,450 meters. Alright? So the time it will take him to what lap? 7 laps. So it's found here. So distance equals speed times time. The question what was to calculate time. So time is equal to distance over speed, right? So the distance, 7 laps, 2,450 at a speed of 1.4 meters per second. So 2450 divided 1.4, just calculate that. That's 1,750 seconds. Next, Tafari runs 1 lap of the track in 68 seconds. Determine the number of laps Tafari can complete in 1 hour running at the same speed. How can we do this now? So Tafari will run 1 lap. So Tafari run 1 lap in 68 seconds, right? How many laps? So he can complete now X laps, X amount of laps. In how many laps will he run in 1 hour? Now 1 hour, let's put everything to seconds. So 68 seconds. So laps, 68 seconds. And so 1 lap map to 68 seconds. So he will complete now X laps in 1 hour. Now let's convert an hour to seconds. Now an hour, 1 hour is what? 60 minutes. 1 hour is 60 minutes, and 60 minutes is 60 times 60. 60 times 60, so 60 minutes is 3,600 seconds. Alright, so 3,600. Alright, so 1 lap in 68 seconds. How many laps can he complete in 3,600 seconds? 3,600 seconds representing 1 hour. Alright, so we can say 68x equal 3,600. Divide both sides by 68. So x equal to 68 divided by 3,600 divided by 68, which is 53 rounded off. Alright, so 53 laps. So he can complete 53 laps in 1 hour. Next, Nathan completes running 1 lap of the track every 72 seconds. Tafari start running at the same time from point L on the track. Each completed a number of laps. Each completed a number of laps of the track. Calculate the least number of laps that each will complete before they are both at point L again at the same time. So Tafari completes X amount of laps. Nathan completes X amount of laps. Let's put this question into perspective. So Nathan completes a lap every second. So Nathan completes a lap every 72 seconds, right? Tafari completes a lap. What time does it take for Tafari to complete a lap? Look at Tafari again. Or every 68 seconds. So Tafari complete a lap every 68 seconds. Now the LCM of 68 and 72. The LCM of 68 and 72 is 1224. So in other words, in 1,224 seconds, they will meet at the start of the track at point L. Alright, so this means that the file will have how many laps now. So if I divide 12